Yaskawa.
Hello, my name is Matt Pelletier, and I'm going to demonstrate how to connect and use a Wago IO device to the MP2300 SIEC using Modbus communication over Ethernet. And let's start out by just looking at what hardware it is that we have here. The Wago device is a 750-841 field bus coupler, and connected to that are 4 digital output slices, 4 digital input slices, an analog output, and an analog input. And before I show you how this is done, I just would like to show the final result, which is that we have 3 input words and 3 output words that are sending the data to this device. So for the digital inputs, right here, I have the value in hex, and below this I have the analog inputs, both 1 and 2 analog inputs per slice. So look at the value of the digital inputs, and I'll turn on some of those inputs now. So I turn on input 1, and that's bit 0, so I see a 1 in the monitor. Then I turn on input 2, that's bit 1, converted to hex, that's a 2. And I turn on input 3, that's bit 2, which in hex is 4. And finally input 4 is bit 3, so you see the value 8. Take a look now at analog input number 1. I have a power supply connected there. And below that we have the analog output. So if I were to type a value into that, right here, I can type in 32767, that's the maximum, 10 volts output. Click overwrite and look at my multimeter connected to that. You see I get 10 volts. I could do half of that, 16,384. And my voltage goes down to about 5 volts. And I can also set the digital outputs. I'll do that, and this is in hex, and I'll set those to hex F0, F0, and I'll turn on half and turn off the other half. And there we have it. So this is what you want from a programming standpoint, is you want to have these variables that have the data that you need. So how did we get there? Let me show you this now from the beginning. So we'll start with a blank project. I'll do File, New Project. So I've started here now with a new project, and the basic steps that we'll need to take are to configure the device in MotionWorks IEC configuration, to save and cycle power, and then to create manually the variables and considering the appropriate addresses at the same time. So the first step is to use the configuration. This is where the major part of the work is done. And I will go to the TCP IP settings, see if I can connect here. The address of this controller is 15.22. You put in the address that corresponds to your controller and hit connect. You need save change prompts. You can say yes. And then since I did cycle power with the config switch on, you always want to do that, I'll just use the configuration found in auto discovery. And now I'm online with the configuration. You can see that for simplicity I have not connected any servos to this controller, so there's nothing under the Mechatrol Link 2 area. And to add Modbus device, go right here to the Modbus area and I'll add a device. To add a device, you go down to the bottom right, add slave device, click on that. Start by giving it a name, and I'm going to call this name Wago IO. My Wago's IP address is 192.168.15.100, and the next field is status variable, and what that means is that when I click save here, it's going to create for me a variable that tells me the status of this Wago IO, whether it's connected or not, basically. So I just need to give that a name ahead of time. I'll call it Wago underscore status. The update interval is set to 50 milliseconds, and you can leave that. You would not want to set that any lower than your interval for your program execution, which by default is 10 milliseconds. You would just set that appropriately. I'll leave that at 50 and click Add. And now that I've added that device, you can even see that it gives it the name Wago IO under the Modbus tree, Wago IO. If I click on Wago IO under the tree area here, I now need to define what these columns show here, the IO group, function code, starting address, etc. And the way you do that is to the bottom right, click Add Data Block. You're presented with this dialog. Now this is where you really need to understand how your device works and how Modbus works with that device. And so I'll go through that quickly here for the Wago device. This is the manual for the Wago 750-841, and it shows how Modbus works and which Modbus registers are read. For example, reading from the analog inputs will be words 1 and 2 for each analog input, 3 and 4 for the next one. Reading the digital inputs would be, in this case, the third word. So you have to use the documentation to figure this kind of thing out and know which function codes are used and which Modbus address will be used for the particular part of the device that you want to access, inputs or outputs. So what I've done here is I've summarized that manual in this diagram just for training purposes here. And we can see that for the Modbus output address, the digital outputs will be at address number 3. It's 4 outputs each, so 16 total. That'll be the 16-bit address will be at number 3. The analog output has 2 channels. That'll be at address 1 and 2, 16 bits each one. And we'll use function code 16 to write data to this. And the variables that we'll use, we'll have to make these in the next step here as are listed here. These are the variables that will be written using function code 16 to write to those. And likewise for the inputs, there is the digital inputs will be at Modbus address 3, the analog input will be at addresses 1 and 2. There are 2 analog inputs to this slice, and those will be read in using function code 4, read input registers, and they'll be read in to these variables that we will have to create. These variables listed here, Wago AI01, 02, and Wago DI. So with that information in mind, we can now fill in this data block field. The IO group, this is just the group name that you'll see in your global variable list. So for IO group, I'll start with the inputs, Wago in, I'll call it. And the function code used to see the inputs was read input registers. Starting at address 1, Modbus address 1, and I want to read items 1, 2, and 3. So addresses 1, 2, and 3. So 3 items is the number of items. And click Add, and it adds that here. For the outputs, I'll do that as a second data block. Call them Wago out. This function code will be to write multiple registers with a starting address, again, of Modbus address 1, writing 3 items, and click Add. And here you can see the summary then of each of those. So the next step is very important. That step is to save. And before I save, I want to show what's going to happen here. Right now, if you look at your project and you look at the global variables under View, Global Variable Declarations, you'll see that you have certain groups that are created by the template. As an aside here, you see this Modbus groups, Modbus function code 2, 4, 5, 6, etc. This is only used with the controller if your controller is a Modbus slave. Now, in this case, we're a Modbus master, So we're not going to use these groups. What's going to happen here are new groups will be created. And so when I save, it's going to create those groups. Let me point out a common problem is an I/O driver fail. And it's because users forget to save and cycle power. What's happening with this error is that the program knows it has Modbus IO, but the controller doesn't know yet because it has to be rebooted to see that change. So please always save and cycle power. Okay, so I've cycled power, and now I can see that if I go back to the global variables, I have global variables that have been added, and the groups according to the group name that I've made have been added. So my Wago IO is added here, Wago in, Wago out. Those are all the things that I typed in. It's also added the LIO01 module, since it had found that. I'm just going to minimize the LIO01 since we won't be talking about that here today. So it's created the Wago status variable. I'll talk more about that later. So now it's time to create the variables. As a reminder, the variable names that we were going to use to send the output was Wago AO01 as an integer. So let's just go through and create these. I guess I'll start here with the Wago inputs. And so what I'll do is right click at the left side of the group and choose insert variable, and then I'll type that in. This is the inputs. So I'll start with the first analog input, call it Wago AI01, and this was an integer, so I type I, brings up integer as the type. Just tab over here, and the address field is very important. The addresses are given to you. That's why what's important to do is you just have to look at the address range that's given. When you hit save, it gave this address range. It's going to depend case by case which addresses are used. In my case, it's telling me I can use bytes 3216 through input byte 3221. So for this 16-bit integer, I'll be using bytes 3216, 3217. You put the starting register, and so you type in the %IW, that means input word 3216. That's going to use bytes 16 and 17. And hit enter. If you get anything red, that means you probably have the wrong data type or the wrong address here. I'll now make the other analog input. Insert variable, right click on the group, insert variable, Wago AI02 for the name, type I for integer, tab over a couple times, and now what is the next address that will be available? Well, I said I'd be using bytes 3216 and 3217. The next byte available will be 3218, so I'll be using %IW, that's input word 32. 18 uses bytes 18 and 19. Hit enter. And finally then for the digital inputs, I'll right click insert variable. I'll call this Wago DI. This one was a word. We'll see later how to use each bit individually. So W for word, it just pops up, I tab over, and the last part of the range is going to be bytes 32, 20, and 21. So I just put IW for input word 32, 20. And that will use the words 20, 21, and that's the final range of this group. Do the same thing now for the outputs. Right click on the group, insert variable. The Wago analog output, Wago underscore AO01 is an integer. Leave it as a global variable. And this has a similar addressing scheme. %QB3216, that means output byte. But I'll be starting at QW. I need a whole word for the analog output, QW3216. And again, insert variable, the Wago analog output AO 02 as an integer, and percent QW3218, and finally insert another variable. This will be the digital outputs, Wago underscore DO. This is a word, since I want to look at each bit individually, and that final address available is QW3220. Uses bytes 20 and 21 since it's a word. Hit enter, and that's the way it is right here. I'm just going to put these in the right order. One thing you can do here is you just click on a whole row and you can move these around. So I'm going to move this Wago analog output 1, and we'll move that up. You can see the red line there where it's going to insert. So you can put those in any arbitrary order. So at this point I've created all of the variables as per my plan. I've created all of these variables, and we've set up in the config tool the function codes that we'll be writing to and the Modbus addresses that will be written to. It's now time to make the program and run it. So I want to make the program and run it. I go to Make, and under the Project Control button I'll download this program. Download and do a warm start or cold, and close the resource box. And there you have it. That's how you set up the configuration and the variables to communicate over Modbus with the MP2300 SIEC controller to a Wago 750-841. Let me talk about one more thing, which is the Wago status. This Wago status variable is very important and useful. And the best way to find information about this is to go back to the configuration. So I'm going to go to the configuration again. And in the configuration there's an online help. So I'll go to the contents, and under the section on Ethernet connections, you can open that part, and there's a whole section on adding a Modbus server slave device. In fact, this is a good reference when you need to do this in the field. As far as what we've done here, the same exact steps are outlined here as well. These are all the steps that we did with a slightly different example. And finally we get to the part here about the status variable. So the status variable it's a 16-bit word, and it's this bit here, bit 12, which you want to see that one on. And that's why back in our program we want to see this in hex. This 1 is indicating that bit 12 is on, as per this help. And what you wouldn't want to see is the no connection bit on, which would be you'll see a 1 in that value. We're going to do an example with that here later. And then if you have any exception codes, those would be shown here below. There's a little key here of what those codes mean. Another thing is there's this in process bit, and sometimes you see that one blink on and off. If this bit's on, these 4 bits would make a hex 4. So when you look here in our monitor, you see that flashes to 4 sometimes. That just means that it's in process, and that's expected, and that's just fine. So at this point I'd like to show a little bit more about how to use these variables now in your program, and the Wago status variable in your program. And to do that, I'd like to turn it over to Kevin Hull.
One more thing to point out here about using a Wago remote I/O device. In general, you can create additional variables, as we've done here now, for the first 6 inputs and outputs. This is handy because now we can actually look at the same I/O points 2 ways. We have the original way we entered it when we were reading the single register, and now we've made bits, and they look at the same memory area. So the same 3217, and we have them listed as bits here for both inputs and outputs. And we've gone ahead and made a small ladder example to show how you can use those in a ladder program. And actually you can do it 2 ways in the ladder program as well. You can either refer to the word and then a specific bit within the word, or to those new bit type data variables we created. So now we can see that if we press on certain inputs, then the outputs will be reflected back out to the Wago device. So if we press on input 3, for example, then output 3 lights up. And additionally, we're showing the use of the Wago status bit. That's bit 12 within that word. And we're using that as kind of a monitor, so we're only running this ladder code if indeed the Ethernet connection is healthy. So, for example, now if we unplug the Ethernet cable from the Wago device, we can see that this bit will drop out, and then the normally closed contact of that same bit will allow us to see that there's a failure on that communications channel to that Wago device. And then reinserting the cable, once again, the status will change back to a healthy state. And then we can again monitor the I/O on that device. So once again, if we press input 6, we'll see output 6 come on. Okay, and there you go.
This concludes the remote I/O configuration with Modbus TCP e-learning video. Please check our website for more information.